Now, suppose we wanted to do something else with this idea of sets. Suppose I had two sets. More specifically, suppose I had a set of trucks, which I'll denote by the set A and the elements T1, T2, and T3. And suppose I depict this with the figure like so. And this is element T1, truck 1. This is element T2, truck 2. This is element T3. And suppose I had another collection, which is the collection of routes, which I'll denote by R. And what I'll do here is and you know what, let me take a step back. I'll actually denote that by the set B. And suppose I had R1, R2, and R3, 3 routes. And I again depicted it by a similar figure, route 1, route 2, route 3. And so the question is, how can I assign each truck to each route? What I can do is actually create what's called a mapping. And I can basically assign each T1 to the first truck to the 3 routes. Put differently, I can say, truck 1, I want you to take route 1, I want you to take route 2, and I want you to take route 3. Likewise, suppose I did the same for truck 2. That is, I assigned truck 2 to route 1, truck 2 to route 2, truck 2 to route 3. And suppose I did the same thing for truck 3. If I did this, then I might ask, well, what is the collection of assignments themselves in this situation? And in this situation, the assignments are actually represented as follows. I have T1, R1, T1, R2, T1, R3. I have T2, R1, T2, R2, and T2, R3. And last, I have T3, R1, T3, R2, and T3, R3. Put differently, I'm not talking about the trucks or the routes, but I'm asking what is the collection of trucks assigned to routes. And that collection of all possible trucks assigned to all possible routes, okay, where this here is what we refer to as a tuple. That is, the order matters. The element here can only be from this set. The element here can only be from this set. When I have this collection of these, in this case, 2 tuples, because there's 2 elements here, I have what is called the Cartesian product of the sets. So generally, a Cartesian product of 2 sets, A and B, is represented by AXB, is the collection of all elements A and B, such that A is in A and B is in B. Another way of representing this is by writing the collection of A and the collection of A and B, such that A is in A and B is in B. And this is the way it used to be represented, where the single element represents the element in the first position, and 2 elements where the element not in the first position represents the element in the second position. But this is just a nice near way of doing it. And by the way, you might recognize this as seeing X and Y from your algebra days. Well, that's the same notation. In this case, this is the AB is just equal to is just equal to shorthand, the A and the B collection here. Anyway, that's in a nutshell what the cross product of two sets, or by the way, this is called cross, not only Cartesian but cross product. The Cartesian or the cross product is very easy to find. So for example, suppose that A is equal to A and B B is equal to 3 and 4. Sounds strange, but we can find that the cross product of A and B is equal to A3, A4, B3, B4. Right? Start at each element, go and assign to each other element in the other set. Do that for all elements. By the way, you're not restricted to only sets that have the same size. I could have a size of 1 and a size of 3 here. And I could do something like A cross B is equal to A4, A5, and A6. And there you have it. That's what we call the cross or Cartesian product. And from the cross and Cartesian product, we can define something called functions and relations, two concepts which we will discuss in our next video.